Hi and welcome in our YouTube channel Computational Design, and in this video I want to share with you something that I found accidentally while just checking the Rhino Common API to check some of its functions. And so the question is, did you know by any chance that Rhino had a function inside its Brep class where you can create a multi-pipe geometry? We know that in Grasshopper we can just go to the surface and we can add a pipe component and maybe a pipe variable where along the curve you can give some parameters and then choose the radius at some parameter. But the main component that we usually use is just a pipe with just one radius, right? But actually deep inside Rhino Common there are some hidden gems actually. So let's check how to create a thick pipe where you have two radii. So it's like you're creating a wall around the pipe or around the curve. Let's check how to do this in C#. So let's just add a C# component, and all we need to add is two radii so that we can modify the pipe section. So let's call the first one radius A and give it a type double, and then add a radius B and again give it a type double, and here we will somehow choose the radius that we need. So let's just go ahead and try to write this code. So first of all we need to create a NURBS curve or an interpolated curve. So let's just create a set of points to create this curve. So I will just create a list of point 3D object, call it points, okay. Let me zoom in a bit so that you can see. And now I'm just going to create some random list of points to generate this interpolated curve. So let me just create a for loop. So I'm going just to create a new point 3D, call it point, and let's just give it an x of I, a y that is maybe sine. Yeah, so let's just create a sine curve, and in this case we'll give it the sine of I, and yeah, maybe we'll add the same integer of I at a z. And in this case let's just add these points. Add these generated points to the list. So I'm going to close this here, and now we have a list of points that are set as a sine wave. Okay, now let's create this curve. So to create this curve we will just say curve you say equals, sorry, curve dot. So we're calling the curve static class, and let's just create interpolated curve, and let's add our points. So this is the list of points, and let's just have a degree 3 curve, and let's check our curve by viewing it in this object here. So yeah, our curve is drawn here. Of course we can adjust it, we can make it a bit taller, we can actually change the sine wave, so we can just multiply the y by 2 to make it something like this, maybe by 4. Okay, and now let's just create this thick pipe, and let's check how to do this. So to create this thick pipe you need to call the Brep class. So we'll create a Brep, call it thick pipe, and this will be equal, or we will generate it using a method inside Brep called CreateThickpipe. And inside this method there are a lot of fields that we need to add. So first of all we add our curve, we'll add the two radii that we created as inputs. So I'm just going to say radius A and radius B, and then let's give it a false local blending, and let's just add a pipe cap mode. So we will say pipe cap mode dot flat, and then let's check the other fields, required fields. So here it's false, which is the Boolean fit rail. So we can fit the fit rail or not. So I'm going to say false, and then add those two tolerances for the absolute tolerance and angle tolerance, and I'll give both 0.001. Now if I go ahead and just try to, let's just modify the output A and call it thick pipe, and let's check what's going on here. Okay, so here you can just start creating a thick pipe. This component is actually hidden inside Rhino interface, and inside Grasshopper there is no such thing called thick pipe inside Grasshopper itself, but it's actually evident inside Rhino common API, and that's why I really like coding with Rhino common. See you in the next video.